Okay, what I want to think about is, okay, it says we started with 20 inches. No, that's just the start. That's how much snow is there, right? But then it says it melts at 2 inches per hour. Now that is the rate. Again, you can identify a rate with the word per. It's communicated that way. 2 inches per hour. 5 calories per day, right? 10 miles per hour. That's a clue word that tells you. No, it's not. But what does that mean is going to be happening to the amount of snow over time? The height of snow. It's going to decrease. And then this is the numerical amount by which it will decrease each hour. So we're asked to write to create a table here. So I have X, I'm going to put that as hours, okay? And Y will be snow inches, okay? Just inches of snow. So they've given us a template, 0, 1, 2, 3. I'm going to go ahead and put 6 down here. But how do I begin filling out the table over here? If I know that every hour it loses 2 inches.
Put 20 next to 0.
20 at the start. So 0, we want to think about the starting value. Okay, kind of like when you learn how to count. We miss out on that, don't we? When you learn how to count in preschool, you're like, 1. Wait a minute. There's numbers before 1, isn't there? All right, even before we even wrap our minds around that. Where does a stopwatch begin? 0.
So why don't they do that? Like, why is it 0 carrying number?
I think that's a flaw in the way we introduce things. Maybe I'll just experiment with my kid and say 0, 1, 2. Claire's the only one I can do that with, so we'll see. All right, so 20 inches at the start, says Quentin. 18.
16. 14. 12.
Was this 1 hour?
No.
6 hours.
So I've actually. So this was plus 1, plus 1, plus 1, but now it's plus 3. And so what I did here was minus 2, minus 2, minus 2, but I went up 1 and down 2. That is a rate. I went down 2 inches as I went up 1 hour. Down 2 inches, up 1 hour. So if I go up 3 hours, how many inches should I lose?
Down 6.
Should go down 6, and I should be at 8 inches of snow. Okay, that's a proportional relationship. Every hour, you lose 2 inches. Now, look, if that was really hard for you, would it be all right for you to put the 4 and the 5 in between to make sure you were doing it according to the correct pattern? Of course it would. Okay? But I wanted you to think a minute. Now, what do each of these are pairs of numbers. What do each of these represent?
Rates.
No. We use the rate to get them, but each of them as a pair represents
A ratio. Coordinates.
coordinate pair, a point. A point.
Ratio.
So,
How does that equal a coordinate then?
because it's an X and a Y.
But what if then like the Coldplay song? That's not a coordinate.
What are you talking about?
That's an album.
All right, anyways. So, let me zoom out a little bit here, see if I can fit this on your screen here. Where would 0, 20 be if this is, we know that this is the y-axis and this is the x-axis over here.
It would be really high on Y.
It would be really high on y, sure. Okay, now look, I know you guys like to have your boxes to count. I'm not going to give you that right now. I'm just going to put what Quentin said, really high on y, because up here has an x value of
0.
0. I didn't go left or right any. Okay, so this is 0, 20. And then where can I put my next point?
Down a bit.
Down a bit.
Side.
So straight down?
No.
No?
No.
To the side. It's to the side.
Check it out. I'm going to go down 2 inches, and then I'm going to go
Over 1.
over which way?
To
To the right.
Yes. Okay. All right, so when you're reading words on a page, you go what direction?
Right.
Left to right. A graph is no different. We're going to read it left to right. So I'm going to go down 2 inches and then over 1 inch. And again, I don't have the boxes, so I'm not limited by counting boxes, but I'm just going to put 118 here. And and I'm going to try and continue that pattern. 2, 16. Now this is not to scale, so it's going to end way too early. But what I'm getting at here is that if we connected these, that would make my line, right?
Maybe.
That would make my line. It definitely would. Okay? So, this is all you're expected to do in Algebra Half. Be able to get this. Okay?
What are we expected to do in algebra?
Well, in algebra, I'm now going to go ahead and ask this question, and it'll be extra credit on your test, which will be a week after next. But what is well, hang on. I think I might still ask you to do this. Y equals. So if I'm looking for the equation, remember we introduced this on Monday. Y equals X, blah, blah, blah. It's a relationship between Y and X. So we have to think about, well, what is happening to the amount of snow over time?
I have the answer. Am I allowed to say it?
It's what? Decreasing. All right. Now Quentin thinks he's got the answer for the equation.
Yeah.
What do you get?
-2 times the time plus 20.
Okay. So will you, since the time was X, we'll say -2 times the time plus 20. How'd you get that?
Because -2 times 0 plus 20 is 20.
Okay. So this point fits into it. Okay.
-1 or 1 times -2 is plus 20 is 18.
Okay, plug in another point. 1 times -2 is -2 plus 20. It matches up with 2 points. Guess what? If you can decide that it matches with 2 points, you are right. Quentin, I'm going to give you credit for Monday's homework and today's homework because that was an excellent job. Right? If you could do that consistently, you are almost ready for Algebra 1. Okay, now let's talk a little bit more about why in the world this is what the pattern is. Now look, what if I had said, what if you're like me and you prefer to see the equation in a chronological way? What I mean by that is I could say y equals, it starts at 20 and then it takes away 2 inches per
Hour.
Okay, per. What do you think, what operation do you think that word means? It actually means multiply. If I told you it's $10 per ticket and 6 people are going to the movies, what's the cost? 10 times 6 is 60. So per, I understand where you guys could get division, but in most cases it will mean multiplication. Now, we won't look at any of the tricky ones where per means divide, but for our class, huh?
Like 2 Finleys per group.
Not if there's 4 groups. That would mean 8 Finleys. Right? Alright, so 20 minus 2x. Shh. Let me tell you what I was most impressed with when Quentin said this. He said -2 times the time.
So when either one of those?
They're both the same thing because the 20 is positive, the 2 is negative. So the order doesn't matter as long as the signs match up. Okay, so again, this is the final event for this type of problem and probably for our class in terms of what we're going to do with graphing lines. So we make a table based on a pattern given in words. From the table, we realize that those are points on the graph, and we can then try to come up with a rule or equation that relates the 2 variables. Okay? So the part that we're going to study today actually has to do with the clue words that tell you what operation to do. Per, of course, we're going to write down means multiplication. Okay? Most of the time. Okay? We'll just have to be careful.
You gotta write down most of it.
Yeah, we'll do that. That's fine. So, last question for the primer, right? This primer is like a heavy hitter here. What are the coordinates of this point and what does it mean?
It's the 1 line.
It means there's no more snow.
It means there's no more snow. How do you know that, Quentin?
Because snow hit 0.
Snow at 0. So y is the snow. And so we could label our axis here that snow, by the time it gets here, y will be 0. So that will be 0. No more snow. And so the meaning of this point is... Huh?
We're done?
We're done with the snow?
Yeah.
The snow is
No, that's
What are we answering here with the X?
The time.
How long it'll take the snow to melt.
A lot of time.
What? Ella?
10 hours.
10 hours. How'd you get that?
Well, if you divide 20 by 2, it's 10.
So let's think about that. If you divide 20 by 2, you just kind of did that in your head. What if we plug in 10 for X here? 2 times 10.
2 times 10 is
20 minus 20.
0.
0. So 10 hours later, the snow will be gone. That is the meaning of this point, and that is one of the reasons why we have to get pictures of math. That's what a graph is, a picture of the math. Now, if it seems like I'm going really far ahead than we've been going in this class, I sort of am, but I think most of you are ready for it, and it's okay if you don't feel really good about it just yet, okay?
I just don't understand
How to get this?
every time.
All right.
I understand it for that.
That's going to take practice, and it's okay to not have it just yet, okay? One thing I will point out, though, for some of you who are looking for an always or a never, right? Anytime a teacher uses the word always, you should write down whatever they're saying. So you always can associate this point with the constant. You can always associate this point with the constant in your equation. And I'm going to go back over that with the activity from Monday. Okay?
A constant.
A constant is just a number. It doesn't have a variable beside it, right? We won't go into what it's called just yet. Maybe I will, because
What is what called? Wait, you always associate
the constant is called a y-intercept. And I think you can probably figure out why in the world I would call it that.
Intercept.
Because intercept is
What is intercept?
what word does it sound like, folks?
Intercept.
Sounds like intercept, intersect, right?
Which means
Which means cross paths. Why won't it let me? Okay. Come on. Doesn't want to let me make it full screen. So I guess we're stuck there. But anyways, it's called the y-intercept because look, guys, look at where the point is. It's on the, what do you call this line?
the y-axis.
Yeah. So it's not rocket science. If it intersects the y-axis, it's the y-intercept. Okay? Intercept is used as a noun to illustrate that it is intersecting a location. Okay? All right, but that's the only always I'm going to give you. No, it's not. I'm going to go ahead and tell you this one too. Shh. Act like you guys have something better to do right now.
I do. I have a lot of better things to do.
Right now.
Yeah.
You can't leave here. So, no, you don't.
I can leave here if I wanted to.
All right, come on, guys. Look. What did we call this 2 inches per hour? The rate. Hey, we've been talking about unit rate with proportions anyway.
Really?
Yes. So, look at how I illustrated the rate. Negative 2 inches per hour. So I could say that was down 2 inches every 1 hour. Oh my goodness. Is it really that simple?
So, negative 2
It's negative 2 because the snow is going.
down.
Yeah. Now, last point of emphasis. The coefficient of your variable is the rate. The coefficient of your variable is the rate. Every time. Every time.
Why? What if there's like one exception? You said you would say.
The coefficient of your variable is the rate. Okay?
That makes sense.
Every time.
It doesn't really make sense.
Yeah, it does.
Doesn't make that much sense to you, Luke? Well, think about what we're doing, what the variable represents, Luke.
The variable represents the number.
The time in this case. So every hour, I'm going to take 2 away from whatever the hour number is. Actually, I'm going to multiply it by negative 2. So if the hours were 4, I would say negative 2 times 4, because each hour I've lost 2 inches. Times 4, that's 8 inches of loss. Okay, so it's just a way to represent the pattern. Now, that's the purpose of writing it this way. It's a conventional way to write an equation, which is a rule between two variables. Okay? Remember, x was hours. Okay? So this is a way that we can make predictions about things based on a few data points. Okay? You will do that in Algebra 1 where you're given a couple of values and it says, okay, when's the snow going to be gone? Okay? If it says, when's the snow going to be gone, you want to be able to answer that question so then you can know, when can I go out and play without getting sloshy? Does that sound backwards? You guys are like, when's the snow going to be gone? I don't want it to be gone. So, again, this is just a way we represent a relationship between variables. I know this seems like a fast-forward leap based on what we've been doing, but Quentin hit it on the head when he said we're doing algebra today. We're representing a relationship between two quantities. We just use x and y to represent the quantities, okay? Does that make you guys nervous?
Yes.
Why? Oh, well, guess what? That's good. That's good. So, let's see now if the activity from Monday makes a little bit more sense. Anybody need this up anymore? I'll come back to it if you do. Okay? All right. So, oh no, I lost it. So, real quick, why can't I make this full screen? All right. Anyways, this is not. Can we exit full screen somehow? Shh, guys.
I love Blippi.
Exit full screen. Is that it? What? This is really.
Your eyes wide.
All right, guys. Can y'all get it together, please? Luke, you can go walk around with them if you can't. Be quiet. I know that might please you, but come on, man. Oh, no, what just happened? Why do I have two cameras open?
Jump scare warning.
Jump scare warning.
Wait, how did... Oh, it's your computer.
It's a picture-in-picture. Oh, no, what just happened?
I like this.
All right, well, we're stuck with the small screen, so we're going to do the best we can with it, okay?
I understand these.
Okay, so, this is killing me. All right, hang on. Let me see if I can,
No, not really. You just didn't tell me on Wednesday. Like, I remember it for like a minute.
I did.
No.
help. I can't even. No. So, what we're going to do, for y equals x plus 4, we're going to think about something. We're going to write down what I just told you, that the number beside x is the pattern or the rate, and then the constant is the number that you start with. So, here's the problem though. I didn't give you 0, 4 on any of the graphs. I gave you 0, -4, but would -4 go along with the plus 4? No. So that's not right. It's got to be one of these. But what I can do is make a few more points. So 1, so if I go up 1 and I look at what the pattern number is, it says 1. So I'd add 1 to the 4, I'd get 5. 2, 6, 3, 7. That's just a picture from the software I used. Okay, so if you look at these points, 1, oh wait a minute, I skipped over it. There it is, right there, 0, 4, and 1, 5. And as Quentin reiterated, if you find 2 matches, you're done. It has to be that line. Okay, so this is going to be table D. Okay, and now what we're going to look at, we're going to look at the graph. So if it's table D, then I need to find
It would be
0, 4
E.
is right there. 0, 4. That's the only one that has 0, 4.
Oh.
Can I zoom out a little bit?
Where does it get to? 0?
Oh, that's what happened. Unzoom, buddy. Can I not unzoom, buddy? Oh, there we go. All right.
It's right there on the
So it's graph F. It's graph F. And then, let's keep going. Let's just keep going. The descriptions, I'm not going to worry about. So what about number 3? Did anybody get the table for number 3? So I've already used this one. I've already used B. What'd you get?
I don't remember. I don't know.
A? All right, let's think about it. Does A go? So there's the constant. So I always associate the constant when the x is 0. Okay? But again, this goes along with a particular location on the graph too, doesn't it? So table A. Now let's look. 0, 1, 0, 1, 0, 1 is right here. But this one's a little bit different. This one's a little bit different. And you will not notice it just by counting the squares. So if I teach Algebra 1 next year, I'm going to make it my goal to kind of deprive you of the squares. Because that will force you to have to do the math.
Wait, why would you square? You don't teach Algebra 1?
Maybe. I said if. I said if.
I would like that.
Alright, so here's the thing. What's the pattern in number 3? What's the pattern number?
2x plus 1.
The pattern then is the 2. Okay? So the 2 helps us see how fast or slow the line changes. And the hard part here is the coordinates here are 5, 11. And is that on the table? No, but 613 is. 613 is.
I like that.
Now think about something, okay? This 2 shows us how fast the y values are going up. That's why I called it the pattern, okay? So that must mean that number 4 is table C and graph G. Table C and graph G. Now we can use just one part of this to prove our answer, that graph G has a point at 0, -4. It's right there. Okay?
What part was it?
What about B's graph? Why do you have a J?
What about B's graph? B.
That's the equation.
So table B, graph. Oh, I did the
that's the
situation. Oh, I didn't give you the graph for that one, did I? So that would have been
Wait, is this the one that we
H.
By,
I got that. No. It's not
what is
graph.
it called? Is it always called?
All right. So listen, guys. I don't want to make it more complicated than it is, because there's only so much you're expected to do here in Algebra Half. But the big idea for us to make sure we can get it is how to match up, how to make a table from points or from an equation and then plot the graph. That's it. Okay? Everybody got that?
I think I don't
So, I'm going to give you one opportunity to do that.
Do what?
Make a table and graph the line.
You get to make
And I want you to use 3 points. Okay? So, y equals -3x plus 12. Okay? So again, what I want you to do, I want you to make a table, and then I want you to graph it. If you have graph paper and you want to use that, great. If you don't have it, you don't need it, that's fine too. What's up? Remember, I'm going to deprive you of that luxury anyway, so it's probably better to get some practice now.
Okay. Wait, so we have to make a table.
So make a table. That's what the left side is. This is our table.
Okay.
And then graph. Once you've made the table with your 3 or more points, plot the points to create the graph.
Do a little 2, 4, 6, 8, 10.
All right, now look. Can I give you some advice? If possible, you always want to have one of your points include x equals 0. So you definitely want to do a x equals 0 here and find out what is the y value that goes with that, because, as I just mentioned, that's a really important point on your graph. Now, how could you prove that to yourself or someone else? Isn't it always the same? No. X equals
I think I
X.
actually know it.
Yeah. Now, why does that make sense?
Because if you multiply that by 0, 0 plus 12.
Basically cancels it out, right? Okay.
Oh, we're supposed to make one according to that. Yeah. I thought we were making up our own. Me too. Oh, the one about I saw after.
What do you think? You think about it?
Is it only on Tuesday? Okay. Tuesdays are like days where I have the most stuff to do.
For like school or take care of stuff?
No, like just overall.
Oh yeah. It's just an hour. It's just in the morning. And I think it was helpful. So think about you email me.
Hey, Mom.
You don't have to email me everything, but one might help. You could, but I don't have any. Yes!
Okay, so I just got one little question.
If you decide, okay, x equals 0, plug that in. What's negative 3 times 0? No, don't write anything. Don't write anything. Do it in your head. What's negative 3 times 0? Who cares? It's 0. That's why it's important.
Wait, is that a 0 right?
No!
Oh.
What's 0 plus 12?
12.
Yes!
Oh, so it's 12.
Yes!
Yay.
Automatic. Okay?
0 and 12. And then it goes 24.
So yes, you heard my fun conversation that I told you should always plug in 0 for x as one of your points, because that means that's the corresponding y value. Okay? The start amount. All right? That was a point on the graph. Now let's try 1. Okay? We plug in 1. What'd you get there?
You got.
Anybody plug in 1?
Yeah, I got 9.
9. All right, now let's think about that. Why did 20?
12 minus 3.
Yeah.
Oh, that's all it is.
Well, let's do it again with 2. Luke. Shh. I only want to hear from Luke on this one. Can you tell me what this next number would be? Are you sure? Or are you just trusting Finley? Is Finley the kind of guy who would lead you astray?
6.
It is 6. He's right.
I knew it.
Now, how do we know that? There's 2 reasons.
You minus 3.
Okay, the pattern is down 3. Yes. But you got to be careful with that, because I might skip some numbers here. The pattern is minus 3, so every time you go up on the x, you go down on the y by 3. That is the meaning of this number. Okay? Now I'm going to trip you up a little bit. I'm going to put 5.
Okay.
So instead of trying to do the pattern, there's another thing we can do. Since x is 5, I can substitute 5 for the x. Negative 3 times 5 is what? Negative 15 plus 12.
Is
Negative 3. My man.
I didn't do that to get it right.
No, you're good. You told me what the answer is. Oh, you did it a different way?
Yeah.
That's fine. That's fine. Now, guess what? What do each of these represent?
Me? Point.
That's a point, yeah. So look, 0, 12 is up here. 1, 9, 2, 6, 5, negative 3 is going to be way down here. Because, wait a minute, we learned how to plot points long ago in a distant land.
Wait, if you connect a point to make a straight line.
Yes! That is why we call these, well, if I did a better job of my points, yeah. Okay? So, We just graphed the line by doing what? What was it that we needed to give ourselves a chance to graph the line?
The equation.
Well, the equation led us to the points, and the points gave us the graph of the line. Okay? Now, listen. When you get to Algebra 1, you will make the jump from the equation to the graph. And you won't have to do a table. Some of you may be able to do that now. But I don't expect you to be able to do that in Algebra half. Okay, so for us, this is the technique we're going to do. Make a table of points, and then plot the points in order to graph the line. That is what you're going to have to do on your test.
Do we have to make the table?
For now. Yeah.
Wait, how many more special groups do we have before this test?
2.
Oh, we do? Okay. Let's go. Can we, like, study this every... Wait, when's the test? Because I'm a little confused. Special groups.
Thursday, 2 weeks from today. It's the last Thursday before spring break, and we will have another test after spring break, too. I want you to have 2. All right, so I have one final thing. Anybody need this up anymore?
No.
So I got a couple of things I want you to write down. I'm not going to give the whiteboards out. I didn't have a chance to do that. But we're going to take a look at algebraic phrases.
Algebra.
Sounds complicated. It's really easy.
Can I use it?
No, that's what you said.